There are times we want to declare a variable, but we don't necessarily want to assign an initial value to it. Sometimes we do that when we're declaring maybe a UI component in our code, but that component has not yet been created. That's probably the most common use of this. The problem in Swift, when we declare a variable, before we can reference that variable, we must have it be assigned some value. So here I have XYZ as a double type variable, and then I want to print out the value of that, and I get an error. And the error says that XYZ is being used before it's initialized. So what I can do is, instead of declaring this as a double, I can just declare this as an optional data type of type double. And to do that, I simply put a question mark after the data type. This is a generic type called an optional, and in this particular case, this optional will contain a double. The question mark simply means that this variable may or may not contain a double value. In this case, I haven't assigned anything to it, so its value is nil. And when I print out XYZ, we can see that the value shows it as being nil. Now, what if I assign something to that? If I say XYZ equals 15.78, I've assigned a value to it, and you'll see that the value assigned to it is a generic type of sum. And so I see sum 15.78. And then when I print this out, it says XYZ equals optional 15.78. I've heard optionals described as a gift, and that gift has to be unwrapped to see what's inside of it. So if I want this to be 15.78 and not optional 15.78, because I can't do math on the optional, I can unwrap it. And I unwrap it using an exclamation mark. So now I'm getting XYZ equals 15.78. It's giving me the value that's contained there as a double, not as a double optional. All right, I'm going to select these two lines and paste in a different block of code here. So here I'm evaluating to see if XYZ is nil or not, meaning it doesn't have a value. Now again, if I haven't declared this as an optional, I'm going to get an error because I can't reference the value of XYZ simply as a declared double type that has not been initialized. So by putting the question mark there, we've said this may or may not contain a value. And now in our if structure, it's okay with if XYZ is equivalent to nil, and it actually is because we haven't assigned a value. It's going to print XYZ has a nil value. If I assign a value then to it, XYZ equals 3.14, now it's no longer nil, it's going to do the else, and it shows the value here of XYZ. Now again, it hasn't unwrapped this, so I'm getting an optional 3.14. If I unwrap it with my exclamation mark, then it's going to show me the value. I can come back and assign a nil value to XYZ because I've declared XYZ as being able to contain a nil value since it's an optional. If I try to do that with a variable that was not declared as an optional, we'd get an error. Just to show that it took that nil value, I'm going to copy this and paste it, and now we see that showing it has a nil value. And as I mentioned, if I took another variable such as ABC, declared it as an int, and I tried to assign it a nil value, I get an error. If, however, I declared that as an optional integer type, now it will accept the nil. Well, I'm going to assign an initial value here instead of nil of, let's do 15. So notice it's sum 15. If I then had a variable, we'll call this def, equals ABC times 2, I'm going to get an error because I can't do math on this sum 15. What I need to do is unwrap it. This is explicitly unwrapping an optional with that exclamation mark. And now def equals 30. So that's called explicit unwrapping, using the exclamation mark to unwrap an optional. I can also create what's called an implicitly unwrapped optional. And here I'm going to declare an optional with an exclamation mark rather than the question mark. So let's do ZYX, and I'll declare this as an integer, but I'm going to declare it with an exclamation mark. So it has a nil value. It is an optional. But what the exclamation mark says instead of the question mark is I guarantee that when I reference this, it's going to contain a value. Therefore, go ahead and unwrap it automatically. Now, if I try to unwrap it before I do that, I will get an error. If I assign a value then to ZYX, it doesn't provide the output here as being sum34 because it's automatically unwrapping ZYX. In fact, if I go ahead and use that in an expression, so ZYX times 2, it goes ahead and unwraps ZYX implicitly, multiplies by 2, and assigns the value of 68 to val. We see this happen a lot when we're working with storyboards. Back in that very first video where we kind of explored Xcode, we dragged a label to our code to create an IB outlet. Just to refresh your memory on that, let me pull that up. So remember, we control dragged this label over to our code, and it created this line. And we're creating an IB outlet as a variable that we've named LBL welcome of type label. But notice this, there's this little exclamation mark there. That says this is an optional. It's an optional type UI label. It doesn't have a value at the point where our code is being instituted because at that point the storyboard has not yet been created. When the storyboard is created, it assigns this label to that variable LBL welcome. So what we're saying here with this exclamation mark, or what Swift is saying, because it did this for us automatically, is that I guarantee that when we reference this label a little bit later, such as here, it's going to contain some UI component that's a label. And that's how Swift implements optionals, so we don't get caught up in this idea of creating a variable that doesn't get assigned something, or is referenced before it is assigned. All right, let me look at one other piece of code here. This is something called optional binding. Paste in my code. And on optional binding, we can validate that the optional contains a value and unwrap it all at the same time. So here I have a variable called myOptional. It's an int optional, and I assign it some value of 3. And I've declared this with the question mark, so it's not going to automatically unwrap or implicitly unwrap. And we use what's called if let. So I'm going to assign another variable, which is myOptVal. It's going to equal myOptional. Now I'm not unwrapping it here. All this is saying is if this contains a value, then assign it to myOptVal. And then I can use myOptVal in statements within that if structure. So myOptVal is being printed out here as a value of 3, and then I use it in a switch statement. So it's generating the case of 3. Now if it didn't contain a value, if that value was nil, it would hit the else fork and print this. So let's just try that. If I were to comment this out, now I'm getting my optional has a value of nil. Let's come back here and change this to a 2. And now it's hitting the case 2 and printing out 2. If I made this, say, a 12, I'm going to get the some other value. So if let a new variable name equals our optional variable, that will assign the value to that new variable name, and we can use it in our if structure. And that's called optional binding. In summary, we have 2 ways of declaring optionals. The first is to use a question mark after the data type. This creates a generic optional of that data type that may or may not contain a value. But in order to use that, we have to unwrap it. And we can use the exclamation mark then in unwrapping it explicitly, or we can bind that optional to another variable using if let. So here I bound xyz to zyx, and that will evaluate to see if it's got a value, and if it does, it then transfers that value to that new variable, and we can use that variable in our calculations. The other way to declare an optional is to use the exclamation mark, which declares it as an implicitly unwrapped optional. We're guaranteeing that when we reference it, it will contain a value, and it automatically unwraps it. So I don't have to use that exclamation mark to unwrap it. In my line there where I'm assigning xyz times 2 to abc, it does it automatically. It's implicitly done.